we take this value of the covariance. So usually the covariance is not a very useful description of the data, but it helps us calculate the correlation, which is much more useful. And so the correlation can be found by taking the value of the covariance between the x and y variable and dividing by the product of the standard deviations for these variables. So I should probably find that really quick. So let me do that. Okay, so for x I have 1.83. So let me say, I'll call this S with a little x next to it to indicate this is the sample standard deviation for the x variable. And then sy is 2.22. All right. So to calculate our correlation, we're going to take the value of the covariance that we've calculated already, and we're going to divide by 1.83 times 2.22. Okay, and that gives me 0.98. Okay, so to say a few words about correlation, it's it's not something that just exists in nature. It's something that it's a method that someone created. It's a statistic that's used to describe the strength and direction of a linear association between two numerical variables. And when the relationship between the two variables is very strong, you see values for the correlation that are either close to 1 or close to -1. So let's just give a few illustrations here. So if I have a relationship that's not exactly on the line, but fairly close, the R value, the correlation is going to be close to +1. I might have something like 0.99. Now, if I have sort of a similar situation, but negative relationship, so here's y, x, y, and x. So the R value associated with this would be negative. And let's just say 0.97 is a pretty strong relationship between those two variables. Okay, so when would we get values close to 0? So values close to 0 are going to indicate very little association between x and y. So in other words, knowing the behavior of x is not very informative in understanding the behavior of y. Whereas up here, I would say that knowing the behavior of x is very informative, because if I know that x is a larger value, I could predict that y is a larger value, is also going to be a larger value. But if I have sort of a cloud like this, maybe I see a very slight upward trend if I were to draw a straight line here, but the values don't appear to be very closely associated. So I might get something very small, like r equal to 0.12. And then, we get values somewhere in between. Here I have a scatter plot that suggests there is an association, but we also have some error, right? So knowing x does help me predict y a little bit, but my predictions for y would probably be off by a certain amount. So R might be definitely negative because I have a downward trend here, but it might be something like 0.5, I don't know, 0.59 or something like that. Actually, probably. All right, so that's how we can attach the values of the correlation to scatter plots. And I do want to show you one useful tool that I found. Okay, so this is a game you can play to get some intuition, build some intuition about the correlations and how they manifest in scatter plots. So, you know, some of them are harder than others, but at least this gives you an idea of how correlations might be attached to scatter plots. No, that's never happened to me before. Okay, so I was off. These were really close. Let's get some new plots. Try that again. Okay, so I want to look for, let's see, 0.58, 0.54. Those look kind of close, but they're both positive. So I'm going to go ahead and guess that this one 0.58 and this one's 0.54. And then, why do they keep doing this to me? And then I'm going to guess this. Okay, so these were off. That's just mean. Okay, anyway, I think you get the idea. You just, as you practice this, you'll start to just sort of naturally have a sense for what value of a correlation corresponds to. There, okay, I can stop now. What value of a correlation corresponds to the scatter plots. Okay, so correlation measures association. It doesn't measure cause and effect, and it's also important to remember that this only works for quantitative variables. So I couldn't say something like there's a correlation between hair color and eye color, because those are categorical variables. You could say association, that would be fine.